Morning, everybody. Let's start. Now, in the last class, we have discussed some processes. For example, phytoremediation. We have discussed. We have discussed bioremediation. We discussed landfills. Why landfills are a concern. All these things we have completed in the last class. Now, today we'll start with what? We'll start with ozone layer and ozone layer depletion. Clear? Let's start with ozone layer and ozone layer depletion. Now, when we talk about ozone layer is present in where? It is present in the stratosphere. And it is present in the stratosphere from a range of, it is present in the stratosphere from a range of 15 to 50 kilometers. That's the extent of ozone layer in stratosphere, 15 to 50 kilometers. And as far as ozone layer is concerned, ozone is not naturally present in atmosphere. Good morning, everybody. Ozone is not naturally present in atmosphere. It is generated, and it is generated due to the influence of solar radiation on oxygen present in atmosphere. So the oxygen molecules, because of impact of solar radiation, would be splitting to form O plus O as oxygen atoms, and the oxygen atom would be combining with oxygen molecule to form O3, which is ozone. Now, this splitting of oxygen molecule into oxygen atom, this reaction is called as what? This is called as photolysis. And the oxygen ozone cycle is referred to as what? It is called as Chapman cycle. So, when you are talking about oxygen ozone cycle, it's referred to as what? It's referred to as Chapman cycle. So, that's how ozone is produced in the atmosphere. Now, there can be many subjective type questions, many objective type questions asked from this chapter. Many subjective type questions, many objective type questions asked from this chapter. Now, they can ask you a question that if oxygen is present in troposphere, and if not only oxygen is present in troposphere, but also solar radiation is present in troposphere, why then the ozone layer is confined to stratosphere and not present in troposphere? That's the first question. Suppose we say that oxygen is present in troposphere and also solar radiation is present in troposphere. Why is that ozone layer is confined to stratosphere and not present in troposphere? Clear? First thing. See, as far as ozone is concerned, ozone would be manufactured in the lab also. But it would be manufactured in the lab. How? It would be manufactured in the lab by giving an electric discharge, electric charge you can say, from an induction coil to the oxygen which is present in the lab. So we take an induction coil and through this we are responsible for giving electric charge to oxygen, then O3 would be produced in the lab. Clear? O3 would be produced in the lab. Now, this is how O3 is produced. But as far as troposphere, as far as stratosphere is concerned, this is how it is produced, through photolysis and also through Chapman cycle. Clear? There are many benefits of O3 also. When ozone layer is present in stratosphere, it is responsible for what? It is responsible for filtering the harmful UV radiation. Filtering the harmful UV radiation. And we'll discuss the types of UV radiation. But ozone, the benefit of ozone is that it is used as a sterilizing agent for air. Ozone is also used for what? It's also used for purification of water. Whatever RO, the reverse osmosis system that you purchase these days for purification of water, all of them would be having the technology which is O3 technology for purification of water. So, it's used as a sterilizing agent for air. it's used also not only sterilizing agent for air, but also it's used for purification of water. So O3 is used for purification of water also. And as far as ozone is concerned, it has its own benefit, it has its own demerits. It has its own benefits, but it has its own demerits. Now the first question comes that if oxygen is present in troposphere and also sunlight is present, why is that ozone is confined to stratosphere? Now the reason for that are three mainly. First reason is that if we move upward in troposphere, the temperature reduces. But the reverse takes place in case of stratosphere. That if we move upward in stratosphere, the temperature would be enhancing. Clear? If we move upward in stratosphere, the temperature would be enhancing. So what we can see is that if the temperature enhances in stratosphere and temperature reduces, in case of troposphere, there would be convectional currents, because the hot air, when it becomes hotter, it would be rising upward. In case of troposphere, there would be convectional current. In case of troposphere, there would be mixing of air. So if there is mixing of air, if there are convectional currents, it means that if ozone layer is formed, it cannot stay for a longer period of time. It cannot stay for a longer period of time. Sorry, because mixing of air is taking place or convectional currents are present in troposphere. But when we talk about just one thing, we have completed odor pollution. Have we completed, tell me, because 2 days and I have many classes. Have we completed e-commerce waste? Tell me, have we completed e-commerce waste? In the context of landfills, just reply. Have we completed phytoremediation? Just reply. Have we completed that? Just reply. Immediately please reply, because then I means that we have to complete all those things. Have we completed e-commerce waste in the class, last class, as a part of landfill? Have we done that? No. And we haven't completed the measures also. No. Okay. Fine. I know. So, first of all, let's complete that portion. Not e-waste, e-commerce waste. Fine. I got it. That what needs to be done. But odor pollution, have you written also? Okay. Completed. Okay. Bioremediation completed also? I think bioremediation has been completed. Okay. Fine. Have you written odor pollution? Have I dictated odor pollution? Have I dictated odor pollution in the class? Tell me. Have we dictated odor pollution? Some part is left. Okay. Bioremediation then. Okay, fine. I got it. See. Let's seize it here. We'll come to it again. But, okay. I said that I'll continue and see. It's 2 days in between gap, and I have 10 hours of class every day. So it becomes difficult to remember that what I have completed. From now onwards, I'll note it down, that what I have completed in the class. Yes, you wrote odor pollution. See, we have discussed in the case of landfills, that landfills are a concern. Why? Because there are collapsing landfills, one case, and we have cited the example of Ghazipur landfill as collapsing landfill. But we also have discussed was that landfills burn also. And in burning landfills, we have discussed what? That when burning of landfills takes place, then incineration of plastic waste would be taking place, and incineration of plastic waste is responsible for emission of dioxins and furans. Dioxins and furans are what? Dioxins and furans are gases which are considered as carcinogenic in nature. So, one thing that is there, that incineration of waste in landfills would be responsible. And tell me if I have covered up dioxins and furans or not. So, incineration of waste is responsible for emission of dioxins and furans. Now, when you are talking about dioxins and furans, we have discussed in that, one thing we have discussed that landfills collapse. We have discussed example of collapsing landfill as Ghazipur, that's in Noida. Then we have discussed that landfills also continuously burn. And the best example of burning landfill is what? The best example of burning landfill is the Deonar dumping site in Mumbai. As an example, this can be quoted. Then we have said that the areas nearby the landfills, in those areas, underground water would be polluted by heavy metals. And one example that we have cited is the heavy metal like lead responsible for contamination of underground water near Bhalaswa landfill. These things we have discussed. Then we discussed that landfills are a source of what? It is a source of odor pollution. Now, what remains here is landfills is also considered to be a dumping site of what is called as e-commerce waste. E-commerce waste would be constituted how? It would be constituted by the packaging material which is used for e-commerce, which includes plastics, which includes paper, which includes bubble wrap, which includes cardboard boxes. And we can see that 30% of solid waste generated today is nothing but e-commerce waste. 30% of solid waste generated today is nothing but e-commerce waste. And this e-commerce waste is a growing concern. Now, in India, there is no law related to e-commerce waste, because of which it is coming to landfills, and also coming to drains. And this happens to be a concern. Now, e-commerce waste is a concern. Why? First thing, there is no law related to it in India. Second thing is what? That bulk of it is what? Bulk of it is, okay, I got it. What has been discussed, what not has been discussed. Fine. Now, we can see that bulk of it is what? Bulk of it is paper and cardboard boxes. Now, it means that it comes at the cost of forest cover. Then also we can see that as far as e-commerce waste is concerned, plastic is an important constituent of e-commerce waste, and these plastic would be consisting of a number of chemicals. Now, the chemicals present in plastic include BPA, that is bisphenol A, it includes phthalates, it includes also BFR, it also includes vinyl chloride, and all these chemicals prove to be detrimental for our health. Clear? Then also we can see that this type of waste also consists of what? It also consists of styrofoam. Styrofoam, when you are responsible for purchasing your mobiles online, or suppose from retail shop also you purchase, you can see there is a white sheet wrapped over the mobile, and this white sheet wrapped over the mobile is called as what? It is referred to as styrofoam. Now, this is an extended form of polystyrene which is reported to be what? Which is reported to be carcinogenic in nature. So, it's an extended form of polystyrene which is reported to be carcinogenic in nature. Clear? All these are concerns related to e-commerce waste. And then, in the measures that we would be discussing for landfills, we'll discuss that what needs to be done for odor pollution, because half the dictation has been left, and what needs to be done for e-commerce waste. Clear? And then we come to dioxins and furans. Clear? Right on landfills, another perspective is landfills is also considered to be a dumping site of landfills is also considered to be a dumping site of e-commerce waste is considered to be a dumping site of e-commerce waste. E-commerce waste. Landfills is also considered to be a dumping site of e-commerce waste. This waste is constituted by the packaging material. This waste is constituted by the packaging material used for e-commerce. Packaging material used for e-commerce. This waste is constituted by the packaging material used for e-commerce. About 30% of the solid waste generated today, about 30% of solid waste generated today, is e-commerce waste only. About 30% of solid waste generated today is e-commerce waste only. E-commerce waste only. 30% of solid waste generated today is e-commerce waste only. It consists of paper, cardboard boxes. It consists of paper, cardboard boxes, bubble wrap, paper, cardboard boxes, bubble wrap, plastics. Now the first concern is what? The first concern is that much of this waste can be easily recycled. But due to lack of regulations, these wastes are coming into drains and also into landfills. Much of this waste can be easily recycled. Much of this waste can be easily recycled. Now that's the first concern. Much of this waste can be easily recycled. But due to lack of regulation, it is coming into landfills. And drains. But due to lack of regulation, it is coming into landfills and drains. Now that's the first concern. And the second concern is what? That bulk of it is what? Bulk of it is paper and cardboard boxes. It means that it comes at the cost of forest cover. Since bulk of it is paper and cardboard boxes. Bulk of it is paper and cardboard boxes. It comes at the cost of forest cover. It comes at the cost of forest cover. And the third concern related to this is what? The third concern related to this is that as far as e-commerce waste is concerned, plastic is an important constituent. So we can see a number of chemicals are present in plastic. Write down. Since plastic is an important constituent, the chemicals present in plastic, plastics are health hazards. And these chemicals include what? These chemicals include phthalates. It also includes bisphenol A. Bisphenol A is used for making the plastic products soft. It also includes BFR, that is brominated fire retardants. Phthalates are used for making the plastic products more flexible. It also includes vinyl chloride. And all these are what? All these are health hazard because they are dangerous to health. They are dangerous to health. Fine. And also we can see that in this waste, styrofoam is also present. So styrofoam is what? Styrofoam is an extended form of polystyrene, and this is present in this waste, which is reported to be carcinogenic in nature. Write down, in this waste, styrofoam is also present. A styrofoam is also present, which is an extended form of polystyrene, which is an extended form of polystyrene, and is reported to be carcinogenic in nature, because this would be responsible for causing cancer. So and is reported to be carcinogenic in nature. Clear? Fine. So all these are the concerns which are related to e-commerce waste. And then in the remedies that we provide for landfills, we would be discussing what are the remedies for odor pollution also, and what are the remedies for e-commerce waste also. Clear? E-commerce waste also. So for the remedies that we would be discussing, all these things would be discussed first. Now this, and we can see also that as far as burning of waste is concerned, burning of waste in landfills, particularly plastic waste, is responsible for emission of gases, and these gases are toxic gases. And two toxic gases happen to be a matter of concern. One is what? One is your dioxins, and second is what? Second is furans. One is dioxins and second is furans. Now when we talk about dioxins and furans, we can see that both of the gases, are reported to be carcinogenic in nature. So dioxin is also carcinogenic in nature, and we can see furans is also carcinogenic in nature, because both would be responsible for causing cancer. And as far as dioxin is concerned, we can see that dioxin is what? Dioxin is a group of 100 odd gases. So it is a group of 100 gases. And the most detrimental of it is 2,3,7,8 tetrachloro dibenzo p-dioxin, p-dioxin. In short, we can say that this is what? This is TCDD. And we can see this is the same gas which was used by US as Agent Orange in the Vietnam War. Clear? This is the same gas which was used by US as Agent Orange in the Vietnam War. So that's only your TCDD. So without fighting a war, we are exposed to this kind of gas. On the other hand, when we talk about furans, we can see that furans are represented by a chemical formula. C4H4O. That's about furans. It's represented by chemical formula C4H4O. As far as dioxin is concerned, we can see that the source of dioxin is not only waste incineration, and particularly in waste incineration we say that plastic waste is responsible for emission of dioxins and furans. Plastic waste is responsible for emission of dioxin and furans. But the source also happens to be what? Also happens to be pesticide making. Pesticide making. The source also happens to be not only pesticide making, but also we can see the source happens to be pesticide making, and also paper and pulp bleaching. Paper and pulp bleaching. So all these would be the source of. But as far as the source of urine is concerned, the source of urine is only one. Source is only one, and that is what? That is nothing but waste incineration. Waste incineration. Everything has been depicted on the board, and copy that also. So we have said that in landfills, waste incineration is responsible for emission of toxic gases, which includes dioxins and furans. Both of them have been reported to be carcinogenic in nature. Now, dioxin is a group of 100 odd gases, most detrimental of which is 2378 tetrachlorodibenzo P-dioxin, or in short we can refer to as TCDD. The source of dioxin is not only waste incineration but also pesticide making and paper and pulp bleaching. On the other hand, furans would be represented by a chemical formula C4H4O, and the source happens to be waste incineration. Now, the significance of dioxin and furan is not only due to the fact that it is emitted from landfills and happens to be toxic in nature, but significance of dioxin and furan is also due to the fact that the Biomedical Waste Management Amendment Rules of 2018 were responsible for banning the use of chlorinated plastic bags and gloves in hospitals, because when they become waste, incineration of this waste is responsible for emission of dioxin and furans. Incineration of this waste is responsible for emission of dioxins and furans. So that is why we have taken dioxin and furans as the two gases here, and that is also part of landfills that we are talking about. Clear? See, when we talk about what is the way out for landfills, now some of the governments, they say, state government, that say that landfill should be shifted from one area to another, but this won't be regarded as a wise method for the problem. Why? Because you are responsible for removing pollutants from an area, but in turn you are responsible for creating a new polluted area. In turn you are responsible for creating a new polluted area. So that's the concern first. So it would be better that we would be using some vegetation for this purpose, some trees for this purpose, and these trees have the ability to suck the pollutants, derive nutrition from them, and they are responsible for discharging waste products which do not hamper the environment in any way. Now these trees, would be called as hyperaccumulator, and the process of phytoremediation would be used for clearing landfills. So that's one thing. The process of phytoremediation would be used for clearing landfills. The second thing is what? That we would be also responsible for establishing a buffer zone near the landfills. And outside the buffer zone, the residential areas should be established, so that the impact of collapsing landfills is not there, so that the impact of odor pollution is not there. And we can see, as far as odor pollution is concerned, some other measures can be taken. We can use the system of what is called as odor hours. Odor hours means any hour which has 6 minutes of recognizable smell. In the West, it is termed as odor hours. And there is a prescribed limit for odor hours in the residential area as well as the industrial zones. And the purpose is mainly to check the source of odor, and that can be liquid or solid waste. So this can be. And also for this purpose in India, strict olfactometry standards need to be established. If suppose we establish strict olfactometry standards, then the odor pollution would be reduced as such. As far as e-commerce waste is concerned, for e-commerce waste, what you be using, we would be responsible for, first of all, the collection, recycling of e-commerce waste would be coming under the ambit of EPR, that is Extended Producer Responsibility. We can have a principle of buyback also. Buyback means, if suppose I am the delivery boy, I deliver the commodities at your footstep, I would be responsible for taking the packaging material back and it can be reused. So there should be a principle of buyback also for e-commerce waste. And the consumer should insist on sustainable delivery of the commodities or delivery of commodities in a sustainable manner, that can be said also. So all these steps can be taken. So way out includes all these steps one by one. Clear? Write down way out. Way out. It won't be wise to sift landfills. It won't be wise to sift landfills, as new polluted areas would be generated. As new polluted areas would be generated. Polluted areas would be generated. But it would be more judicious. But it would be more judicious. It would be more judicious to use the process of phytoremediation. But it would be more judicious to use the process of phytoremediation. To restore balance of that area. Process of phytoremediation to restore balance of that area. Balance of that area. Near the landfills. Near the landfills. A buffer zone should be established. Near the landfills, a buffer zone should be established. A buffer zone should be established. Zone should be established so that the impact of collapsing landfills be reduced. So that the impact of collapsing landfills be reduced. And also that of odor pollution be lessened. And also that of odor pollution be lessened. Odor pollution be lessened. Specifically for odor pollution, let's complete the remaining part of this also. Specifically for odor pollution, strict olfactometry standards. Specifically for odor pollution, strict olfactometry standards. Strict olfactometry standards needs to be established. Strict olfactometry standards needs to be established. Needs to be established. And the system of odor hours should be implemented. And the system of odor hours should be implemented. And the system of odor hours should be implemented. And I have told you that the concept of odor hour is what? That any hour which has 6 minutes of recognizable smell would be termed as what? It would be termed as odor hours, and there would be a prescribed limit for odor hours in both residential as well as industrial areas. The significance is to check the source of smell, which can be liquid or solid waste. which can be liquid or solid waste. Now that's the system of odd-over Rs that we are talking about. So we can also include odd-over Rs. Right, on the system of odd-over Rs should also be implemented. The system of odd-over Rs should also be implemented. Now the third way out is connected to what? The third way out is connected to the e-commerce waste. Right, on collection, recycling and disposal of this waste. Collection, recycling and disposal of e-commerce waste. Collection, recycling and disposal of e-commerce waste should come under the ambit of EPR, that is extended producer responsibility, extended producer responsibility, extended producer responsibility. Now that's one way out that can be suggested. But as far as e-commerce waste is concerned, the second way out is that there should be a principle of buyback also. And you understand that what we have discussed in the principle of buyback. Right down. There should be a principle of buyback. There should be a principle of buyback. Buyback. And principle of buybacks. And it is consumers' responsibility to insist on. And it is consumers' responsibility to insist on. Delivery of commodities, insist on delivery of commodities in a sustainable manner, delivery of commodities in a sustainable manner. So that should be done. But as far as e-commerce waste is concerned, one step was taken by the government of Maharashtra in the year 2018, because in the year 2018 the government of Maharashtra was responsible for imposing a plastic ban, and the plastic ban was extended to include within it e-commerce waste also. So the plastic ban was extended to include within it e-commerce waste also. So all these things can be mentioned when we talk about landfills. So we have discussed the different perspective of landfills, and also what is the way out. Clear? Now come to ozone layer and ozone layer depletion. Now we have discussed what? We have discussed that how ozone layer is formed and where is the ozone layer present. What is the advantage of O3? What are the disadvantage of O3 we'll also discuss. But the first question is that if oxygen is present in troposphere and sunlight too is present, why then ozone layer is confined to stratosphere and not present in troposphere? Now the first reason for that is what? The first reason, let me answer your question. Sir, if incineration is done in a scientific manner, will be helpful to lessen the quantity in landfills? Yes, definitely it would be. Is it scientifically possible to control the emission of furans and dioxin? It's difficult, because best way out is what? Best way out is to remove or segregate plastic from the waste which is dumped in landfills. If plastic is there, burning of plastic, and burning takes place constantly, and burning of plastic would be responsible for emission of dioxins and furans. That's the only remedy that we can have. You can segregate. That's why the Biomedical Waste Management Amendment Rules of 2018 was responsible for banning the use of plastic gloves and bags as such. That's the reason why it was done. Clear? Fine. Now see, we can see that as far as troposphere and stratosphere is concerned, we are discussing that ozone layer is confined to stratosphere, although oxygen and sunlight is also adequately present in troposphere. There are three main reasons behind it. If we talk about the temperature variation in troposphere and the temperature variation in stratosphere, we can see with enhancement in height, the temperature reduces in troposphere, but with enhancement in height, the temperature enhances in stratosphere. The reverse takes place in case of stratosphere. And if this be the case, there hardly would be any mixing of air. There hardly would be any convectional current. no mixing of air takes place, no convectional current would be taking place. There hardly would be any mixing of air. There hardly would be any kind of convectional current in troposphere. So even suppose if ozone is present, even if ozone is present or is formed in troposphere, it won't be stable. Why? Because of convectional current and the mixing of air. Now that's the first reason. Second reason is what? That the intensity of solar radiation for photolysis is less in case of troposphere when compared to stratosphere. And the intensity of solar radiation for photolysis is less in case of troposphere when compared to stratosphere. And the third reason is what? That when we talk about troposphere and stratosphere, we can see stratosphere is a dry region, whereas troposphere is a region where moisture is present. And ozone happens to be unstable for moisture. Ozone is unstable for moisture. Clear? Write down. First of all, the introductory part. Ozone layer is present in stratosphere. Ozone layer is present in stratosphere. Is present in stratosphere. From 15 to 50 kilometer range, from 15 to 50 kilometer range, 15 to 50 kilometer range, ozone is not naturally present. Ozone is not naturally present. Not naturally present, but is generated. Ozone is not naturally present, but is generated. Is generated due to the action of solar radiation, but is generated due to the action of solar radiation, action of solar radiation, action of solar radiation on oxygen present in the atmosphere, due to the action of solar radiation on oxygen present in atmosphere. So I have said that when solar radiation acts on oxygen molecule, it would be splitting to form oxygen atom, O plus O, and this splitting is called as what? This is called as photolysis. And again oxygen molecule would be joining with oxygen atom to form O3. So this oxygen-ozone cycle is referred to as what? It is referred to as Chapman cycle. This oxygen-ozone cycle is referred to as what? It is called as Chapman cycle. So this is how formation of ozone takes place in stratosphere. Clear? We can see that in the lab, ozone is formed how? By giving electric charge from induction coil to oxygen present. Right down in the lab, ozone would be formed. In the lab, ozone would be formed. Ozone would be formed by giving electric charge. In lab, ozone would be formed by giving electric charge from induction coil, electric charge from induction coil to oxygen, electric charge from induction coil to oxygen present in the lab, to oxygen present in the lab, oxygen present in the lab. Clear? To oxygen present in the lab. That would be done. And we can see the advantage of O3 is what? The advantage of O3 is what? That it is used as a sterilizing agent for air and also used in purification of water. Write down. O3 is also, ozone is also used as a sterilizing agent for air. Ozone is also used as a sterilizing agent, sterilizing agent for air and in purification of water, and also used in purification of water, and also used in purification of water, also used in purification of water. Clear? So this is used in purification of water. Now the first question that we will attempt here, that although oxygen is also present in troposphere and sunlight is also present, but why is ozone layer confined to stratosphere? Write down. Although oxygen is also present in troposphere, although oxygen is also present in troposphere, oxygen is also present in troposphere, where sunlight is also present, where sunlight is also present, sunlight is also present, ozone layer is confined to, ozone layer is confined to, ozone layer is confined to stratosphere because of three main reasons. Ozone layer is confined to stratosphere because of three main reasons. Three main reasons. Now what is the first reason? The first reason is temperature variation. Right on the first reason. When we move upward in troposphere, temperature reduces. When we move upward in troposphere, temperature reduces, but the reverse takes place in case of stratosphere. That means temperature enhances. But the reverse takes place in case of stratosphere. But the reverse takes place in case of stratosphere. Reverse takes place in case of stratosphere. Fine. Now if this be the case, then we can see that there won't be any there is no mixing of air or convectional current in stratosphere as like troposphere. Write down. There is hardly any mixing of air. There is hardly any mixing of air. Hardly any mixing of air or convectional current. There is hardly any mixing of air or convectional current. Or convectional current. In stratosphere, hardly any mixing of air or convectional current in stratosphere. As such, the ozone layer formed in stratosphere. As such, the ozone layer formed in stratosphere. The ozone layer formed in stratosphere is more permanent. Ozone layer formed in stratosphere is more permanent. So we can see more stratified, more permanent, and that's why it is called as stratosphere also. Fine. As such, the ozone layer formed in stratosphere is more permanent. Now that's the first reason. Because in troposphere there is convectional current, mixing of air. Even though ozone is formed, it won't be permanent. First reason. Second, the intensity of solar radiation for photolysis. The intensity of solar radiation for photolysis. Intensity of solar radiation for photolysis. Is less in case of troposphere when compared to stratosphere. The intensity of solar radiation for photolysis is less in case of troposphere. The intensity of solar radiation for photolysis is less in case of troposphere when compared to stratosphere. Is less in case of troposphere when compared to stratosphere. Now that's the second reason. Fine. And we can see the third reason is what? The third reason is that troposphere is a region where moisture is present, and and stratosphere is a dry region. In stratosphere is a dry region. As such, we can see that O3 is unstable for moisture. Write down. Stratosphere is a dry region. Stratosphere is a dry region, whereas stratosphere is a dry region, whereas troposphere is a region where moisture is present. Whereas troposphere is a region where moisture is present. Troposphere is a region where moisture is present. The region where moisture is present. Moisture is present. And ozone is unstable for moisture. And ozone is unstable for moisture. Unstable for moisture. Clear? Fine. See, as far as the UV radiations are concerned, we can see that in the stratosphere, when ozone layer is present, it is said that it's responsible for filtering the UV radiation. So if we talk about the UV radiation, we can see that UV radiation would be of three types. UV radiation would be of three types. So first type of UV radiation would be called as what? It would be referred to as UVA. So suppose let's consider here the ozone layer is present in stratosphere. This is the O3 and this is the surface of the earth. When we talk about UVA radiation is not at all obstructed by the ozone layer. It is reaching the surface of the earth and reaching the surface of the earth naturally. And if we talk about the lambda of this radiation, the wavelength of this radiation, the wavelength is from 320 to 400 nanometers. That's the wavelength of this radiation. 320 to 400 nanometers. Clear? And when it is reaching the surface of the earth, we can see when it reaches the surface of the earth, naturally it is reaching the surface of the earth, the adverse impact of this radiation is what? That it is responsible for. Adverse impact of this radiation is what? That this radiation is responsible for aging in humans. And why aging takes place? Because the elasticity of skin gets reduced, because the elasticity of the skin gets reduced. Now the second type of UV radiation is called as what? It is referred to as UVB. So suppose this is O3 and this is the surface of the earth. UVB radiation reaches the surface of earth minimally, negligible. And if depletion of ozone layer takes place, depletion of ozone layer is reported, then it would be reaching the surface of earth in greater abundance. So when it reaches the surface of earth in greater abundance, it would be responsible for diseases like cataract. That would be the adverse impact. It would be responsible for diseases like cataract. It would be responsible for diseases like skin cancer. And if you see the wavelength of this radiation, the lambda of this radiation is from 290 to 320 nanometers. 290 to 320 nanometers. So that's the wavelength of this radiation, which is called as what? Which is called as UVB. This is your UVB. And in the limelight of depleting ozone layer, this is a matter of concern. Why? Because it would be reaching the surface of the earth in greater abundance, and this would be responsible for the adverse impact that we know. See, temperature variation does not take place due to convectional current. Temperature variation takes place how? Temperature variation takes place due to the heating process of stratosphere and troposphere. In case of stratosphere, the heating process is through conduction. So the upper part of the stratosphere would be receiving more heat when compared to the lower part. In case of troposphere, the heating is by indirect method. So first of all, the solar radiation strikes the surface of the earth, and from the earth infrared radiation would be generated, which would be determining the temperature of an area. If suppose the infrared radiation reaches a greater height, then it would be growing feeble, weak, and that's why we say that temperature at greater altitudes would be low in troposphere. And why low in troposphere? Because the infrared radiation is weak in that area. It won't be absorbed. Clear, infrared radiation is weak in that area, it won't be absorbed. So this happens to be the real case. And in case of troposphere, when the hot air from the surface would be rising upward and the cool air from the upper part would be taking its place, a convectional current would be formed. So mixing of air takes place. But mixing of air cannot take place in case of stratosphere, because the temperature variation is different. Higher altitudes in stratosphere would be having more temperature when compared to lower altitudes. So this temperature variation I have discussed. Clear? Now this would be, when it comes to the surface of the earth in abundance, this would be responsible for diseases like skin cancer and cataract. Now the third type of radiation is called as what? It is called as UVC. And if suppose this is O3 and this is the surface of the earth, UVC radiation does not reach the surface of the earth. It does not reach the surface of the earth. And it would be reaching the surface of the earth if no ozone layer is present, but that cannot happen, because if oxygen is present, if sunlight is present, photolysis would take place and through Chapman cycle O3 would be generated. But if at all it reaches the surface of the earth, it would be doomsday for mankind. Why? Because this radiation is directly responsible for what? This radiation is directly responsible for tissue damage. And if we talk about wavelength of this radiation, the wavelength further is reducing from 100 to 290 nanometers. 100 to 290 nanometers. Clear? So wavelength is further reducing. It is from 100 to 290 nanometers. Now that's how, if a question is asked, suppose seeing this figure 3, that which UV radiation is a matter of concern. In the limelight of depleting ozone layer, it would be UVB. Why? UVC does not reach the surface of the earth and UVA naturally reaches the surface of the earth. And if a question is asked which UV radiation would be obstructed due to ozone layer, it would be B and C both. B and C both. Clear? So there are 3 types of UV radiation which I have drawn. You can take, if you wish, you can take a pic of it. 3 types of UV radiation I have discussed. One is called as what? It is referred to as UVA. Second, I have discussed UVB, and third, which I have discussed, is called as UVC. Clear? UVC. So 3 different types of UV radiation I have discussed. Take a pic of it. Everything has been written on the board. No dictation in this case. No dictation in this case would be required. Fine. Clear? See, more harmful for us would be UVC, because if you see, one observation can be seen, the wavelength is getting reduced, but more energetic is the UV radiation. So it means that energy is inversely proportional to wavelength. The wavelength is reducing, but more energetic is the UV radiation. Why? Because it is responsible for more and more of damaging impact. It is responsible for more and more of damaging impact. So more energetic is the UV radiation as such. Fine. So which would be more harmful? UVC would be more harmful. But UVC won't reach the surface of the earth. It is responsible for tissue damage. Death would take place. Fine. And see, if a question is asked like this, that ozone on account of its location can be both harmful and beneficial for mankind. If a question is asked like this, that ozone on account of its location can be both harmful and beneficial for mankind. Let's see how it can be answered. Clear? Can be harmful and beneficial for mankind. Let's see how it can be answered. Now the first thing is that when we say that ozone on account of its location can be both harmful and beneficial for mankind, one can say that when it is present in stratosphere, it is beneficial for us because it's responsible for filtering the harmful UV radiation, UVB, UVC, clear. But when it is present in troposphere, it is harmful for us. Why? Because in troposphere, it is acting as what? It is acting as a pollutant. In troposphere, it would be acting as a pollutant. And as far as troposphere is concerned, in the troposphere, it is acting as a pollutant. As far as troposphere is concerned, we can see as far as troposphere is concerned, it also in troposphere would be considered as a part of, see, if you talk about the National Air Quality Index of India, National Air Quality Index of India consists of 8 indicators. And among the 8 indicators, we can see, among the 8 indicators, what is present? One is your PM 2.5, second is your PM 10. Nitrogen dioxide is present, then carbon monoxide is present, ozone is present, ammonia is present, SO2 is present, lead is present. So it happens to be one among the 8 indicators in National Air Quality Index of India and would be considered as what? It would be considered as a primary air pollutant because directly emitted into the atmosphere. But it is also part of secondary air pollutant. Secondary air pollutant, best example is what? Photochemical smog. So you suppose primary air pollutant like hydrocarbons, we'll study that later on. Primary air pollutants like hydrocarbons and NOx are present in atmosphere. When sunlight acts on it, then oxidants would be generated. Oxidants generated include what? Oxidants generated include nitrogen dioxide, it includes O3 also, it includes PAN also. But for the time being, remember that this O3, ozone, is a part of photochemical smog, which is a secondary air pollutant. Clear? So in troposphere, it would be responsible for being a part of secondary air pollutant also. It is responsible for being a part of secondary air pollutant also, and it is also considered to be a primary air pollutant. Now, surface level ozone or tropospheric ozone would be detrimental for us. Why? Because when we consider ozone, we say that ozone is responsible for respiratory problem among us. When we talk about ozone, ozone is responsible for visibility problem also, respiratory problem, visibility problems, all these are the adverse impact. Clear? All these are the adverse impact. See, PM 2.5 and PM 10, if the particulate matter which is in the atmosphere, the diameter of particulate matter is 10 micrometer or even less, then it is called as PM10, particulate matter 10. So it would be suspended in the air and would be certainly not good for our health. But if the diameter of particulate matter is 2.5 micrometer and less, then it would be not only, in case of PM10, it is called as what? It is called as SPM, suspended particulate matter, because suspended in the air. But in case of PM 2.5, it is called as RSPM, because not only it is suspended in the air, but it's also respirable for us also, so we would be inhaling it. So this is called as RSPM. More detrimental would be PM 2.5. Clear? More detrimental would be PM 2.5. And we can see also that as far as tropospheric ozone is concerned, tropospheric ozone or surface level ozone would be present how? Not only it is present due to the things that we have discussed, that how surface, it is also present due to oxidation of methane. Oxidation of methane is responsible for generating surface level ozone. It is also present due to oxidation of benzene, because oxidation of benzene also is responsible for generating surface level ozone. It is also present due to dust storms, because there is a process through which NOx is removed from dust storm, and NOx consists of what? NOx consists of nitric oxide, that is NO. Now this is considered to be what? This is considered to be nothing but a scavenger of O3. Scavenger of O3. One by one we will take it, because I think that it would be difficult to grasp each and every part. So let's divide it and take it one by one. So write it also, and so that everything is known to you. One question we have discussed, that why ozone on account of its location can be both beneficial. No, we have discussed first that why is ozone layer confined to stratosphere, not present in troposphere. Now we discuss another question, that ozone on account of its location can be both beneficial and harmful for mankind. Write down, ozone on account of its location. Ozone on account of its location. On account of its location can be both beneficial and harmful for mankind. Ozone on account of its location can be both beneficial and harmful for mankind. Can be both beneficial and harmful for mankind. Harmful for mankind. When it is present in stratosphere, and where in stratosphere? The ozone layer. When it is present in stratosphere, it is beneficial for us. It is beneficial for us, as it is responsible for filtering. As it is responsible for filtering. Filtering means obstructing in this case. As it is responsible for filtering the harmful UV radiation. As it is responsible for filtering the harmful UV radiation. The harmful UV radiation. But when present in troposphere, harmful UV radiation, but when present in troposphere, it is detrimental for us. It is detrimental for us, as it is considered to be, a primary air pollutant, as it is considered to be a primary air pollutant, and is responsible for burning sensation in eyes, responsible for burning sensation in eyes. burning sensation in eyes, as well as respiratory problem, and is responsible for burning sensation in eyes, as well as respiratory problem, as well as respiratory problem. Respiratory problem. Respiratory problem. Now that's the first thing. Right now, it is also part of secondary air pollutant. It is also part of secondary air pollutant. So it is itself a primary air pollutant and part of secondary air pollutant also. It's also part of secondary air pollutant. Secondary air pollutant. Photochemical smog is also part of secondary air pollutant. Photochemical smog. Photochemical smog. Clear? So it is considered as a pollutant in troposphere and it's also part of secondary pollutant, air pollutant, and that is photochemical smog. Because the secondary air pollutant photochemical smog is consisting of what? It is consisting of three constituents. Nitrogen dioxide is present in that, O3 is present, ozone is present, and also present is what? PAN, peroxyacetyl nitrate. So it's a part of definitely photochemical smog, and it is one among the 8 indicators in the National Air Quality Index of India. That's why it would be considered as a pollutant. Right now, it is one among the 8 indicators. It is one among the 8 indicators. 8 indicators of. It is one among the 8 indicators of National Air Quality Index of India. Of National Air Quality Index of India. It is one among the 8 indicators of National Air Quality Index of India. National Air Quality Index of India. Clear? National Air Quality Index of India. And we can see that tropospheric ozone is responsible for burning sensation of eyes and also respiratory problem. Write down, tropospheric ozone is responsible for burning sensation of eyes. Tropospheric ozone is responsible for burning sensation of eyes, as well as respiratory problem, burning sensation of eyes as well as respiratory problem. But the thing is, how is tropospheric ozone generated? How is surface level ozone generated? So surface level ozone or tropospheric ozone would be generated in many ways. First way is oxidation of methane. Write down, the tropospheric ozone or surface level ozone. The tropospheric ozone or surface level ozone would be generated in the following manners. First, oxidation of methane. So we can see oxidation of methane results in generating surface level ozone. Oxidation of methane results in generating surface level ozone. Second, oxidation of benzene. And from where we get benzene? Benzene is present in the air from vehicular emission, right down, which is present in the air, which is present in the air, through vehicular emissions, through present in the air through vehicular emissions, which is present in the air through vehicular emissions. And as far as the third source is concerned, we can see removal of NOx from dust storms would be responsible for generation of surface level ozone. Write down removal of NOx from dust storms is responsible for generating surface level ozone, Is that clear? Fine. Surface level ozone. So all these are the sources. And why removal of NOx from dust storm generates surface level ozone? Because NOx consists of NO, which is called as scavenger of O3, because it consumes O3. It combines with it for remove O3. Right down. Because in NOx, nitric oxide is present. In NOx, because it's a combination of nitrogen dioxide and nitric oxide. In NOx, nitric oxide is present. Which is considered as scavenger. Of ozone. Scavenger of ozone. Is that clear? Scavenger of ozone. Now this you have to know, that what are the sources of surface level ozone. So you can see that ozone, on account of its location, can be both beneficial and harmful for mankind. See, when we talk about ozone layer depletion was reported for the first time in 1985. And it was reported from the first time in 1985 over Antarctica. The thickness of ozone layer is measured in a unit. And this unit is called as what? This unit is referred to as the Dobson unit. So we can see in the 1950s, the thickness of ozone layer over Antarctica was roughly about 280 to 320 Dobson unit. 280 to 320 Dobson unit. Now it drastically reduced to 136 Dobson unit in the year 2000, and it drastically reduced to 136 Dobson unit in the year 1985. Clear? So this was a reduction, and certainly the alarm bells were ringing. So immediately Vienna conference was organized, and we can see ozone depleting substances are what? So let's study all those substances. First of all, the report confirming that ozone depletion has taken place. Write down, ozone depletion was reported for the first time. Ozone depletion was reported for the first time. In 1985, over Antarctica. over Antarctica. Where the thickness of the ozone layer, and that thickness is measured in a unit which is called as Dobson unit. Where the thickness of ozone layer over Antarctica in the 1950s was from 280 to 320 Dobson unit. From 280 to 320 Dobson unit. 280 to 320 Dobson unit. And in the year 1985, it reduced to 136 Dobson unit. It reduced to 136 Dobson unit. 136 Dobson unit. And immediately the alarm bells were ringing that how this has happened. Clear, alarm bells were ringing that how this has happened. So drastic reduction from 280 to 320 Dobson unit to what is called as 280, 320 Dobson unit to 136 Dobson unit in the year 1985. So that's your drastic reduction. However, clear, fine. And we can see that as far as ozone depleting substances are concerned, the ozone depleting substances include many. It includes chlorofluorocarbon, it includes methane, it includes nitrous oxide, it includes HCFCs. But even if we take these ozone depleting substances, see, all these are ozone depleting substances, and in some case they are not directly responsible for ozone layer damage. For example, CFC, if we talk about CFC, chlorofluorocarbon, it is considered to be inert. It is never directly responsible for ozone layer damage. But CFC under the influence of solar radiation, would be emitting chlorine. And this chlorine is nothing but a free radical catalyst. Now this would be responsible for the damage. Clear. And how the damage is done? Chlorine would be combining with O2 to form O3 to form ClO plus O2. So this is how the reaction. It's the oxide which is responsible for the damage. And then we can see ClO would combine with O3 to form Cl plus 2O2. So oxygen would be regenerated also. Oxygen would be, so this is the reaction how ozone depletion takes place. So I have depicted the reaction on the board, that is, first of all, the free radical catalysts are responsible for maximum damage. Never pick up CFC for that purpose. So ozone depleting substances although include CFC, but CFCs are never directly responsible for ozone layer damage. Methane is there, nitrous oxide is there, HCFC are there, and CFCs are never directly responsible for damage, but indirectly responsible, because when the solar radiation falls on CFC, then chlorine would be emitted. Right on. Ozone depleting substances include CFCs, methane, nitrous oxide and HCFC. CFCs, methane, nitrous oxide and HCFC. But CFCs are never directly responsible for the damage. as they happen to be also inert. CFCs are never directly responsible for the damage. They emit chlorine. They emit chlorine under the influence of solar radiation. They emit chlorine under the influence of solar radiation. Under the influence of solar radiation. Which is responsible for doing so? They emit chlorine under the influence of solar radiation, which is responsible for doing so. Because chlorine is responsible for the damage. And the damage is done by formation of oxides of chlorine, here in this case. And the reactions include Cl, all these reactions, you know. And the reactions include Cl combined with O3 to form ClO plus O2, and ClO would be combining with O3 to form Cl plus 2O2. That's the reaction that we have discussed. But then do remember a fact that damage to ozone layer would be done more and more by free radical catalyst. And on the other hand, damage to ozone layer, is done more by free radical catalyst, free radical catalyst, which includes chlorine, bromine, OH and NO, OH and NO, chlorine atom, bromine atom, OH hydroxyl and nitric oxide. And among these free radical catalysts, we can see bromine does maximum damage, right? Among these free radical catalysts, bromine does the maximum damage. But bromine is never found in free state in atmosphere. And see, it is never found in free state in atmosphere. So from where it can be extracted? Brominated compounds can be extracted. So brominated compounds can be extracted from one source. And that source is what? That source is brine pools. Brominated compounds can be extracted from one source, and that source is what? That source is brine pools. But where is brominated compounds used? Brominated compounds are generally used as what? They are generally used as fire retardants. Fire retardants means the purpose is to suppress fire. If suppose in this furniture or in this smart board that I have, BFR is used, brominated fire retardants is used. For the time being, it would be responsible for suppressing fire. For the time being, it is responsible for suppressing fire. So if suppose we are using BFR, brominated fire retardants, time being it can suppress fire. How? Because if suppose in this furniture it is used, or in this smart board it is used, if a fire takes place here, due to temperature enhancement, free bromine would be released from BFR, and these free bromine which are released from BFR would be responsible for suppressing the chain reaction which takes place during fire. So that's why it would be called as fire retardants and not fire extinguisher. As such, it would be considered as fire retardant and not fire extinguisher as such. Fire extinguisher is what? Fire extinguisher is compressed CO2, but fire retardants is brominated fire retardants. But see, BFR is present where? E-waste. BFR is present in the textile that we wear. BFR is present in the mattresses also. BFR is present in mainly in your plastic products. Clear? BFR is present mainly in your plastic products. And we have just now discussed the chemicals which are present in plastic include BFR, brominated fire retardants, and the adverse impact of BFR is what? That it is bioaccumulative in nature and it would be acting as endocrine disruptors. Endocrine disruptors. So let's see what is BFR. Clear? Right on. Brominated compounds are extracted. And brominated compounds are mainly used as fire retardants. Brominated compounds are mainly used as fire retardants. Compounds are mainly used as fire retardants. Fire retardants. And when they are used as fire retardants, they are called as what? They are called as BFR. Right on. When used as fire retardants, it is referred to as brominated fire retardants. It is referred to as brominated fire retardants. In short, we write it as BFR. And we can see BFRs are present in number of waste that we have. Right on. BFRs are present in laptops. BFRs are present in laptops, furnitures, textiles, mattresses, and mattresses, plastic products, etc. And we can see as a contaminant, suppose it is present as a contaminant, BFR is responsible for, first of all, it enters the food chain and would be called as bioaccumulative in nature, and second, it is endocrine disruptor. Clear? Then the adverse impact of BFR includes, that it is bioaccumulative in nature. Bioaccumulative in nature means that it enters the food chain, bioaccumulative in nature, and acts as endocrine disruptor. This they have asked you in examination. And acts as endocrine disruptor. So if suppose it is acting as an endocrine disruptor, it means that hormonal imbalance inside the body has taken place, right on, which results in hormonal imbalance, hormonal imbalance. That's about brominated fire retardants. See, in case of NO2 and NO acts as a scavenger of O3. First get it correct. Sir, what is the meaning of that? Scavenger of O3 means that it combines with O3 to form other compounds and removes it from that area. O3 gets absorbed in their surfaces, no. NO would be combining with O3 to form other compounds, and that would be removed from that area. And second, you have written NO2 can react with O3 to form nitrous oxide and O2. Then how NO2 can act as a scavenger? Not NO2 can act as a scavenger, but NO acts as a scavenger. And the reactions are different for that. Please. This is what they asked you in UPSC, that what is the adverse impact of BFR? So it is bioaccumulative in nature, and it is acting as what? It is acting as endocrine disruptor. Bioaccumulative in nature, but it's acting as endocrine disruptor. Is that clear? See, there was a brominated compound, and this brominated compound was called as methyl bromide. Methyl bromide is a brominated compound which has a more damaging impact. It was used as a pesticide in garden initially, pesticide in the field of agriculture initially. But what happened when it was used as a pesticide in the field of agriculture? What happened was that the ozone depletion, it started more and more. So WHO took a note of it and was responsible for banning the use of methyl bromide as a pesticide in agriculture. So WHO took a note of it and banned the use of methyl bromide as a pesticide in agriculture. But then we can see that India was responsible for recently using methyl bromide. India was responsible for recently using methyl bromide, and this was used for fumigation of agricultural produce that we import from other countries. Fumigation of agricultural produce that we import from other countries. So methyl bromide was used. And why it would be used for fumigation of agricultural produce that we import from other countries? Because when we are importing agricultural produce from other countries, along with it the seeds of invasive plants also comes, which is responsible for environmental degradation in India. Environmental degradation in India. So to disallow that, we would be making fumes and passing over the agricultural produce so that the seeds do not reach India or gets destroyed. And this was done. Clear? This was done. But the West raised the concern that how India is responsible for using methyl bromide when it has been completely banned under the Montreal Protocol. Clear? When it has been completely banned under the Montreal Protocol. So one thing is, in UPSC they have asked you about what are the adverse impact of BFR. But a type of brominated compounds, methyl bromide, is also used as pesticide in the field of agriculture. Right on. A type of brominated compound, brominated compound, methyl bromide. A type of brominated compound, methyl bromide is used. Methyl bromide has been recently used by India. A type of compound, methyl bromide, has been recently used by India for fumigation of. Fumigation means you prepare the smoke and passed over it. For fumigation of agricultural produce. For fumigation of agricultural produce, which India imports from other countries. which India imports from other countries. And the purpose was very clear that India did not want any kind of seeds of invasive plants to come to India, because India has suffered because of that. So that should not be done. So fumigation was used. But then the West raised the concern that how can methyl bromide be used for fumigation of agricultural produce, because it has been completely banned in the world. Write down. The Western world expressed concern at India's action. The Western world expressed concern over India's action. Concern over India's action. India's action. As methyl bromide has been banned under the Montreal Protocol. As methyl bromide has been banned under the Montreal Protocol. Banned under the Montreal Protocol. Is that clear? So methyl bromide has been banned under the Montreal Protocol. And methyl bromide is considered to be a class 1 ODS, much damaging in nature. Now see, let's move forward. Now one question is what? That if we suppose we talk about maximum industrialization on earth. This is suppose the earth, so not drawn properly. This is suppose the earth. And we say that maximum industrialization in earth is in the tropical areas of northern hemisphere. That's the region where maximum industrialization has taken place. But damage to ozone layer takes place near Antarctica. Damage to ozone layer takes place near Antarctica. So what are the reasons that we can cite for damage to ozone layer near Antarctica? What are the reasons? Now there are 3 reasons which comes to our mind. One reason is what? One reason is the shape of the earth. Second is what? Second is the rotation of earth. And third is what? Third is the lowest temperature of Antarctica. So let's see how these factors are responsible for. One second. Lowest temperature of Antarctica. See what happens. This area I am saying, the tropical areas of northern hemisphere. In this area, what happens when the hot tropospheric air when the hot tropospheric air mingles with the cold stratospheric air, mingles with the cold stratospheric air. Now what happens due to this? First of all, why the tropospheric air would be warm, hotter? Now tropospheric air is hotter due to global warming. And why so? Because if suppose more and more of greenhouse gases are present in the atmosphere, which is taking place due to industrial emission, more of it would be absorbed by more and more of see in this area, just one second, here we are saying that in this area more of industrial emission is taking place. More of industrial emission means more of emission of greenhouse gases. So the infrared radiation which is generated from the surface would be absorbed more and more of these greenhouse gases. So the temperature of troposphere would be enhancing, but that of the stratosphere is getting reduced. Now stratosphere is getting reduced. Why? Because if more of infrared radiation is absorbed by the greenhouse gases which are present in troposphere more, the escape of infrared radiation to stratosphere would be reduced. The escape of infrared radiation to stratosphere would be reduced. The escape of infrared radiation to stratosphere, the stratosphere would be becoming more and more cooler, and troposphere would be becoming more and more of warmer. Is that clear? So in this case, where we are saying that the hot tropospheric air mixes with the cold stratospheric air, then just like a circulation current, a circulation is generated which is responsible for pushing the emission towards the poles, Clear? Towards the poles. And we can see that the industrial emission would be getting accumulated near the poles. Suppose when I am saying that hot tropospheric air mixes with the cold stratospheric air, a circulation is generated which is called as Dobson-Buer circulation, which is responsible for pushing the emission towards the poles. Clear? And the emissions are getting accumulated near the poles. Why? Because of nearer center of gravity. Suppose here we take the center of gravity. If we talk about this distance is a short distance when compared to this distance. So this would be a short distance. Why? Short distance. Why? Because center of gravity from here happens to be near. Why? Because the earth is flattened over the poles. So if it is flattened from the poles, this distance from the polar areas to the center of gravity would be considered as a short distance. And then when compared to this distance or this distance. So when the Dobson-Buer circulation carrying the industrial emission would be responsible for coming near the poles, it would be absorbed by coming near the poles. Here we can see it would be getting accumulated near the poles, and it is getting accumulated near the poles. Why? Because of nearer center of gravity. So we can see the shape of the earth is responsible for it. It is getting accumulated near the poles due to nearer center of gravity, and we can say the shape of earth is responsible for this. Because the shape of the earth is what? It is geoid, or we can say oblate spheroid. So it is flattened at the poles and bulging out at the equatorial area. We'll take a break and then we'll come and then we'll discuss this, because I think that one in phased wise manner, if we discuss that, would be better. So take a break of lunch break and then we discuss this.